Every time I open the foundry door and I take somebody in there, I said, you're going to step back into 1870s.
Sam Knight. Sam Knight was born in Maine. His family moved down to Maryland, and when he turned 14, he started to apprentice in the shipyards. He did that till he turned 21. After that, he was down in Florida working in a machine shop for a couple of years. And then 1861 came about, the Civil War. He was a Northerner. He ended up getting on a U.S. Navy vessel, was involved in a couple battles on his way back up, and ultimately a year later headed out to California. But he came with a extremely high quality level of skills and was able to get into these mines and build the stuff they needed built. So timber framing, cranes, winches, whatever they needed, he could build it. And that's where he got his start here, until the time he decided, hey, I got this idea.
This is officially a historical site for the ASME, American Society of Mechanical Engineers. And the reason is that during the 1800s, really up until Samuel Knight died, this was more than just a machine shop or a foundry. It was really a full-on engineering operation. They had draftsmen, they had a whole design office, and they made a full line of finished, complete products. Pretty much anything you needed to mine gold. And also, of course, the water motors that this place is so well known for.
Everybody is just amazed at the way things were done back then, how they got things done without the equipment we have today. And they were able to figure it out. And so that's, people, bar none, they just enjoy seeing how things were done before. They're amazed at how they were able to lift tons of iron and move it all through the foundry with those cranes. It's pretty amazing.
Projects began in the company office, where the customer's ideas and engineering requirements were translated into product specifications, blueprints, and diagrams. The original office was located toward the rear of the pattern shop, but it was destroyed in the fire of 1936 that also damaged part of the shop. Several of the overhead timbers still bear the scars from that fire. The current office was built after the fire and is preserved with its historical furnishing. It served as the company's administrative workplace and, during the 1950s, doubled as court for the local justice of the peace, who was also the company's bookkeeper. The process of going from two-dimensional concept to a three-dimensional finished product begins with producing a pattern from which the casting mold will be created. This very detailed, very intricate task fell to the pattern shop craftsman. Most patterns were made with wood, and pattern making demanded excellent woodworking skills, but it required more than simply following the blueprint. Craftsmen had to also visualize how a complicated pattern could be broken into components suitable for casting and then be correctly assembled. Surfaces, angles, crevices, and interior voids all had to be crafted in such a way as to permit molding sand to conform to the shape of the part and still allow the pattern to be removed, leaving behind its imprint in the sand. The pattern maker also had to be knowledgeable in how molten metal would behave as it flowed through the mold and cooled. Channels and gates had to be incorporated into the design of the pattern so the mold would fill properly. As molten metal cools and solidifies in the mold, it shrinks in size. Anticipating this change, craftsmen used special metal rulers called shrink rules that were calibrated to compensate for the amount of shrinkage based on which metal was being poured. The result was a final product that was dimensionally correct. Patterns were given a coat of lacquer or paint, yielding a smoother surface that made removal from the sand mold easier and to protect the pattern from environmental damage for future reuse. The many patterns hanging in the shop today are but a small fraction of the diverse range of products Knight Foundry produced to support the local industry. Before World War II, gold mines were the Foundry's biggest customers. Examples of the many machines produced by Knight Foundry can still be seen at the local Kennedy Mine and Miners Bend. But the government's closure of the gold mines in 1942 changed everything, and the Foundry changed its focus to the local agriculture and lumber industries. Machinery sprockets became an important product because they wore out quickly and had to be replaced often. The Foundry also made custom, ornamental, and decorative items and very large specialty parts. A flask is like a sandbox. Basically, it is a frame made of metal or wood designed to hold the pattern and sand that will become the mold for the casting. Flasks come in a variety of sizes so that the flask with the most appropriate dimensions is selected for each pattern. The material used to create the mold inside the flask is prepared in a machine called a molar that combines together a recipe of sand, water, and bentonite, a clay that holds the sand together, plus any special ingredients. Recipes vary depending on what is being cast. Some castings, such as an anvil or this locomotive grate, are solid. Other castings are hollow on the inside. This might be done to reduce the weight of the casting, but often the cavity is an essential engineering element, as in the case of this pump housing. This pump housing is also an example of three-dimensional objects requiring the pattern and flask to be split into two halves. When working with a split pattern, the bottom half of a pattern is placed flat side down inside of a flask without touching the sides, as shown here with this small locomotive grate. This will become the bottom of the mold, called the drag. In order for liquid metal to flow into the mold, the casting is connected to a series of channels called ingates. The ingates are connected to a channel called the runner, and then the runner is connected to the choke. The choke connects the channels in the drag to a vertical shaft called the sprue, located in the top half of the mold. When the flask is fully assembled, this becomes the path for the molten metal to fill the casting. The sand mixture is placed in the flask and carefully compacted around the pattern using hands and tools. Once compacted sand has reached the top of the flask, it is smoothed out. The flask is then flipped over. To create the top half of the mold, called the cope, the process is repeated using a matching flask and the top half of the pattern, plus the sprues and risers. After compacting with sand mixture, the cope and drag are carefully separated, and the patterns carefully removed. The mold is then powdered with a release agent to facilitate disassembly of the mold. This will create a solid casting. But how to create a cavity in the middle? This is where the core shop gets involved. Cores are made of a mixture of sand and resin and are crafted in a wide variety of sizes and shapes. They are inserted into the mold after the pattern is removed to create the cavity. Here, a pump housing core is placed in the mold. Note the space between the core and the mold that will form the outside of the casting. The flask is then reassembled by carefully aligning the cope on top of the drag. Caps are placed over the holes in the cope to keep the inside of the mold clean. The mold is now ready to receive the molten metal. Flasks vary in size from small enough to be handheld to very large, requiring a hoist to lift them. This yard is where the foundry stores the largest metal and wooden flasks. To the left of the yard is the foundry supply building. It houses patterns and other equipment that support foundry operations. On the front of the supply building is the sand bunker. This fine sand is mixed with water and bentonite to create the tightly compacting sand mixture used to create the casting molds. The raw material for making molten iron is scrap iron. This pile contains all manner of iron scrap, such as engine parts, brake drums, pipes, gears, just about anything made with iron, including the kitchen sink, that can be melted and recycled into new castings. The scrap iron must first be broken into manageable size pieces. Before converting to hydraulic tools, the original practice involved hoisting a massive weight high above the iron pile, then releasing the weight to free fall and shatter the larger pieces. This also sent small fragments of metal flying through the air, with some puncturing holes in the adjacent metal building. These puncture holes are still visible today. The ramp just beyond the scrap iron pile leads up to the charging deck, where the pieces of scrap iron, coke, and other components are weighed out before being added to the furnace to be melted. To the left is a shed with two drums that have open slats called tumblers. Powered by a small night water motor, the larger drum was used to remove sand still clinging to the new castings by tumbling them together with small iron stars. The stars would remove the sand, which would then fall out through the slats. The smaller drum was used to break down river clay into a powder. The powder that fell through the slats was mixed with water to form a dense, malleable clay. The clay is attached to the end of long poles and pushed into the furnace tapping holes, creating a plug to keep molten metal inside. This clay plug is then broken open with a harpoon when it is time to release the molten metal and fill the ladle. Returning down Borg Way and to the left is a corral and open field. This was pasture land for the teams of horses the foundry once used to pull the freight wagons before being replaced by trucks and tractors. At the bottom of the hill is the pipe shop building. Here, the foundry would roll sheets of metal into pipes whose seams were then riveted together. One of the original pipe rolling machines is on display in front of the new machine shop. Currently in disrepair, this building is slated for rehabilitation and will be remodeled into a teaching space, museum, and the foundry archive. These two chimney-like structures are the original furnaces used to produce molten iron. Called cupolas, they are lined with fire brick and refractory cement that can withstand temperatures exceeding 2,700 degrees Fahrenheit inside the furnace. The furnace sits on iron legs attached to a concrete pad. Underneath the furnace is a hinged door that is secured shut and covered with a mixture of sand and clay to insulate the door during the furnace firing. Moving up the cupola, there is a front tapping spout to allow molten iron to flow out of the furnace. A little higher and on the opposite side of the cupola is the second spout for removing impurities floating on top of the molten iron. Next is the blower for forcing additional air into the furnace to increase the combustion temperature. And just below the blower are the round viewing ports for monitoring the molten iron. Toward the top of the cupola is the charging deck, where layers of scrap iron, coke, and limestone are added to the cupola through a door. These layers, called charges, are pre-weighed recipes to provide the right amount of scrap iron to fill the molds, coke to provide the CO2 and heat that melts and reacts with the iron, and limestone to help remove impurities that will float on top of the molten iron, called slag. A typical charge recipe might be 330 pounds of iron, 42 pounds of coke, and 13 pounds of limestone. A typical run is made up of 4 to 5 charges, yielding a total of around 1,500 pounds of iron. After carefully loading the first charge into the cold cupola, a blowtorch is used to ignite the coke at the bottom of the furnace. It will take several hours for the fire to move up the furnace and achieve the temperatures required to melt the first charge of iron. Craftsmen will monitor the process using pyrometers and visual evaluation through the portals. While the cupola is heating, the large iron ladle used to transfer the molten iron to the molds is preheated with a wood fire and then a blowtorch before adding molten iron. When enough molten metal has accumulated in the cupola, a crane lifts the ladle into place at the pour spout. Next, the slag impurities are pulled off the top of the molten iron through the spout at the back of the cupola. Then, a harpoon is used to make a hole in the clay plug in the front pouring spout, allowing molten metal to flow into the ladle. Filling the molds is a carefully choreographed process requiring 2 people to maneuver the heavy ladle full of molten iron, a person to operate the crane, a person to help align the ladle and monitor the fill, and a 5th person with sand to cover any molten iron that might spill out. While the molds are being filled, the next charge is already in the cupola, so that pouring is an almost continuous process until all molds are filled. When pouring is finished, the doors at the bottom of the furnace are opened, and the small amount of remaining charge is allowed to drip out, cool, and be recycled in the next pour. Molds must be allowed to cool and solidify before they can be broken open to remove the rough castings. The rough castings are then handed over to the machine shop for drilling, tapping, and finishing. Against the back wall is the night water wheel. This deceptively simple device had a remarkable impact on mining in the gold country. Since the 1850s, mining companies were building canals to bring water from the mountains down to the towns where their mines operated, creating a reliable year-round supply of flowing water. Samuel Knight realized that such a ready supply of water could be used to drive water wheels. This would provide an alternative to the expensive practice of burning wood to generate steam for driving machinery. In 1875, Knight was awarded a patent for his innovations that redesigned the water wheel's buckets so as to capture the full force of the water. With an efficiency around 80%, the Knight wheel was a cost-saving alternative to burning expensive wood. Suddenly, mining in the gold country became economically viable again. The original system received its power using water from the Tanner Reservoir via the Amador Canal that was completed in 1870 and passed adjacent to the foundry. Using gravity and decreasing diameter pipes, a high-pressure jet of water was created to drive the wheel. Once the night wheel was turning, it powered the overhead systems on line shafts, pulleys, and belts that distribute power throughout the shop. Each machine is equipped with an idler pulley that allows it to engage or disengage with the overhead drive system. And each machine has its own set of pulleys and gears to control the speed and direction of the machine rotation. The entire system is interconnected, so nothing moves unless the night wheel is turning. And while the night wheel produced up to 35 horsepower, some machines required more power than others, and craftsmen had to coordinate their work so as to not overload the drive system. To the right of the night wheel are several important stations that support foundry operations. On the metal deck above your head is the air blower for pushing air into the foundry's cupolas during molten iron pouring. This blower provides additional combustion air for increasing the temperature of the molten iron inside the furnace. Just below the blower deck is a belt-driven air compressor. This machine provides the high-pressure air used in both the foundry and machine shop to power various air-driven tools. Also under the blower deck is the belt repair station. Modern belts are made with rubber and canvas, but the original belts were cow and buffalo hides. Regardless of the materials, belts wear out and must be repaired and replaced. Note the metal clips and pins that connect belt segments to facilitate belt repairs and accommodate the various sizes and lengths of belts used throughout the shop. The machine shop is the final step in preparing finished parts for the customer. Using a variety of precision machines, nearly all driven by the night wheel belt system, machinists convert the rough castings into carefully machined parts and make important components such as gears, drive shafts, and bolts. Looking toward the front of the shop, along the left wall, you can see one of the shop's surface planers known as the gray planer. Used to strip away metal from flat or grooved surfaces, the workpiece is firmly attached to the bed, which feeds the material toward the cutting head in a forward and backward motion, while the cutting head, which can be adjusted to various angles, is moved left and right. This versatile machine, called a horizontal milling machine, uses a rotating tool to finish flat surfaces, bore holes, cut slots, bevel edges, and even produce gears. It differs from a planer in that the part is held stationary while the tool rotates and moves around the workpiece. A machine shop drill press, like this Barnes upright drill press, must be capable of boring holes with precise diameters at very specific angles and into a variety of metals. Belts connect the drill to the overhead drive system, and the speed is controlled by moving the belts from one set of pulleys to another. A foot pedal activates the drill, freeing the craftsman's hands to focus on the workpiece. A wide variety of drill bits are available to meet the specifications of the final product. Near the drill press is a unique variation of the surface planer called the jumping belt shaper. Used for small detail work, the workpiece is held stationary while the cutting head moves both left to right and forward and back. A clever belt and lever system automates this process, freeing the machinist for other work. On the floor across from the stairs is the Marvel draw-cut saw. Cutting metal stock is a slow, time-consuming process. This belt-driven saw was used to free the machinists so they could focus on more skillful tasks. Lathes are large, complex, and versatile machines in which the workpiece rotates, while a variety of cutting tools are applied to the face or side to remove material and shape the final product. The first lathe on your left is the Lodge and Shipley lathe. It has many features found on modern lathes, even though this machine is over 100 years old. Instead of a pulley system and manually switching out gears, it has an electric drive motor and a complex gearbox that allows craftsmen to quickly change cutting parameters. Further down the aisle, also on your left, is the Blaisdell lathe that was built in the 1870s and can machine parts up to 12 feet in length and 24 inches in diameter. Beyond the Blaisdell, closer to the wall, is the New Haven lathe. This is the longest lathe in the shop, capable of handling workpieces up to 24 feet long and 30 inches in diameter. The Foundry modified this lathe by adding a second head to make 2 lathes out of 1. Note that the second head is driven by ropes rather than belts. This is the oldest machine on the shop floor. Manufactured on the East Coast in the 1860s, it was transported by ship around Cape Horn. Thread cutting for gears and bolts is an example of the precision work these lathes are capable of. Using a specific combination of drive gears, the workpiece rotation is synchronized with the cutting tool's movement to cut threads with the correct spacing or pitch and thread angle. The machinist closely monitors the process while keeping the workpiece and tool lubricated. Moving toward the front doors of the shop, you will pass an often overlooked machine, the hydraulic press. Working on the same principle as a hydraulic jack, this powerful device uses water pressure to push together parts with very close tolerances, reshape items, and other operations requiring a focused application of pressure. Between the front door of the shop and the office, you see what is known as the assembly area of the foundry. Knight Foundry often created very large, heavy pieces that were both difficult to move and challenging to position precisely for drilling or surfacing. The foundry met these challenges by designing and building the machines you see in this area. Against the windows of the shop are 2 bull lathes. There are similar machines in the new machine shop and the pattern shop. Bull lathes were designed to work on huge discs up to 12 feet in diameter to make flywheels, gears, and pulleys for the mines. The workpiece is attached to a rotating wheel while the cutting tool is moved across the edge or face. Working with such large pieces would be very awkward for the machinist, so these lathes are built over large pits that allowed the lower half of the workpiece to drop below floor level, giving them the title of pit lathes. Looking overhead, you can see the arc crane that was used to maneuver and position the large pieces. It is one of several types of cranes throughout the building. They are hand-operated using chains and ropes attached to gears, cables, and pulleys. Note the charred timbers above the arc crane from the fire in 1936 that destroyed the office and part of the shop. In the center aisle is a surface planer that Knight Foundry built for very large flat pieces. The workpiece is firmly attached to the bed, which feeds the material in a forward and backward motion toward an adjustable cutting head to strip away metal from the surface. To the left of the office is a unique machine built by the foundry called the radial arm drill press. Positioning the large mining parts for precision drilling would be very difficult using a standard upright drill press. To overcome this problem, the Foundry designed and built their own radial arm drill press. The workpiece remains stationary while the drill head can be moved horizontally, vertically, and in an arc to precisely position the drill.
This is our restoration shop. We do a lot of different projects. We are very fortunate to have been donated a lot of used equipment. We take things and restore old machinery. Some of this equipment needs a lot of work, and some of it is just cleaning up. Once this is done, we take it out and we most of the time resell it. Some of the equipment we get, we keep here for the shop, and everything within this shop has been donated at one time or other. Now we're in the precision machine shop of the restoration department. This room is enclosed because we want to keep it environmentally clean, and we have air conditioning and heating so we can keep the temperatures pretty consistent for the machining we got to do. You'll see the same types of machines at the high school as well. So just a different brand, different sizes. You know, it's a working and training museum because that's why the high school is so important to this program. It's another outreach program in training.
What Ron and his group do at the high school is one of the things I'm most proud of. There are a limited number of shop classes available. So, and Ron and his group identified the deficit, negotiated a space with the high school that was being unused, and he and his group of volunteers relocated machine tools, lathes, mills, presses, everything, to the high school, set up an entire machine shop at the high school. And now Ron and his volunteers teach a machine shop class on a volunteer basis at the high school because the high school doesn't teach that class anymore. And I'm very proud of that. Ron is teaching to students who will be better engineers, better surgeons, better welders. Not everybody's going to college. Not everybody needs to go to college, and we know that. But he's teaching skills that these students wouldn't otherwise receive. And that's important to us. I'm very proud of what Ron's doing. It's a really big deal for me.
Our goal is to turn this into a historic teaching museum. Blacksmithing was one of the most asked questions. When are we going to start blacksmith classes at the Foundry? So we partnered with California Blacksmith Association. They provide the instructor. This is a program that will take you from basic introduction to blacksmithing all the way up to a professional if you want.
Started CBA classes over and over and over until the Foundry finally got their blacksmithing shop openings. I like to learn the old age techniques because I feel like it gives me a much better base to build on for art purposes.
We've had so many, I have had so many people start this program and they've watched all these YouTube videos and they come here and on their first lesson, this ain't nothing like YouTube. And it's like, you know, I would never have gotten this watching YouTube, you know, the whole thing, because that's the big thing now.
I'm starting off really simple like we all did, making chisels, and today I'm making fence staples, but it's all learning the beginnings of how things move. And being a bigger guy doesn't necessarily mean that it's better to be a blacksmith, because I've learned a lot of times that my strength works against me. So there's a lot of finesse that I'm having to learn. And then so sometimes, learning different ways to hold the clamp from different people, tall, short, strong, slender, everybody has a different way. And if we all just kind of work together, it seems to, really be a great experience.
But you come in handy when I need something really walloped, I'll tell you what.
There is that.
It's nice to have a big guy around with a sledgehammer.
Yeah.
We have 2 young students, one 13, one 17. We have 3 gals that are taking the course.
It is a really patient thing. I've been, since I was born in the modern age, and
No.
but with everything being so fast-paced nowadays, it's good to have something that's a bit more slow, a bit more, you have to wait for it. Yeah, it's very rewarding at the end when, you don't get that spark, you don't get it puddling down, you just have this nice piece of, metal that used to be like a coat rack or something. Now it's something completely new, different, and it's very satisfying, I guess the word would be.
You saw us doing the striker you had the blacksmith and the striker, and that's always fun because it's real easy to drive home the fact that if you're the blacksmith, you got to do all the thinking now. And one of the things I've tried to do is every hammer blow has a purpose and, is designed to do something. And as you are in there, every time you hit that, you've got to be thinking, this is my purpose. You're not going to get it all. You're not going to get it on YouTube or any of these videos. You need that one-on-one instruction. Otherwise, you're going to get bad habits. Or it's a mystery to you. It's like, I do it, but I don't know why. Come and learn to do it correctly.
I'd like to feel a little bit some of the soul and the heart of the Foundry here in the gift shop as well.
It's just you want to make a little bit of history accessible, even if it's been poured now. It's based on work that was done, 150 years ago. We started when they did the first tour, and I believe it was sometime in 2017. Whenever we started our first tour, we set up a table with a few things to sell.
We sell the most in the gift shop are the trivets, and customers are very familiar with those, being the old furnace grates from years ago, and these are all original Knight Foundry patterns. And I kind of think of the patterns as the bones of the Foundry. And so I keep collecting different pieces, and I think it really does add to the gift shop. It creates some excitement and some fun, and I get the most of the questions from customers about the patterns. I want to be able to have the gift shop represent all of the wonderful things that we carry.
People buy them for themselves, they buy them for gifts. It's just you want to make a little bit of history accessible.
Most people that just come through on tours really don't realize the amount of hours that our volunteers put in. I mean, we have a group of people, usually there's probably 15 to 20 people that show up every Wednesday morning, and they work all day long, every Wednesday. That's dedication. And to me, our volunteers are just, there's no way we'd be where we are today without our volunteers.
I think the Foundry has been a labor of love for every volunteer who works on it. If, like me, you were starting it, volunteering because you were sort of encouraged and there was a need, people become passionate about the place, and the fact that it's not just another tourist attraction, it's living history, and we want to continue to work to make it something that more people can experience.
There's different skill sets. We have carpenters, we have electricians, we have machinists, we have welders, and then we have people that, let's say they're an accountant or something, which has nothing to do with what we're doing. So those people actually find their own jobs almost. They know what they have to do.
They know they can come in and work on historic equipment, maybe pick a piece of historic machinery and restore it for us. Maybe come in and work on a pour day, pouring several thousand pounds of iron. Where else can you do that?
They're all self-motivated. Everybody that comes down here, I feel they feel like I do. They want to be a part of it, they want to be a part of saving history, and they want to pass on that knowledge to people that come through here and people that take the classes.
There's a camaraderie amongst the group that I think is inviting. And I think once here, volunteers appreciate that, and I really do believe that that's part of the reason we have such a strong and stable volunteer base. We like it here. We have opportunities to share our knowledge and skills here with others. And as a group, we're all pretty nice guys and we get along well.
One of my guys told me yesterday, he says, I'm going to keep coming here until it feels like a job.
This is part of our past, part of our industrial revolution. I mean, this is, and you don't have to be a Californian to appreciate it. And it's wonderful that this is still here.
We have an opportunity to restore the site to its former self, if you will, and we're not far from it. Fortunately, the facility hasn't been messed with very much as time went on. I'm not sure that we fit into a neat category. I don't think we fit into the museum category, personally. What makes the Knight Foundry Complex so interesting, all of the machinery, the equipment, the tooling, the furnaces, they all still work, they're all functional, and we use them. And that makes us different than a traditional museum environment where you can walk through and look but not touch. We can actually have guests in the facility working with the tools. We teach classes, we allow students to come in and actually work with our historic tooling, But we do it in a historic setting, and that's what makes us different than most other educational facilities.
Our mission is to preserve, restore, and educate. And that applies to the buildings, but it also applies to the technology and the processes that were used once upon a time. Still lots to learn as to how they did things back in the 1870s. Do our regular tour day on the second Saturday of the month. And so we have a lot of docents that come in demonstrating different techniques and activities that were actually performed here from a historical perspective. The other thing we do is private tours, and so private tours can be arranged and scheduled, and we do 2 to 5 of those a month. Those are arranged with people that come from all over. I arranged one with some guys on the East Coast who had friends coming from Sweden, and all 4 of them came out here specifically to see this place.
We do offer all-day classes in Foundry practice, very popular, classes in blacksmithing. One of our volunteers is developing a class pattern making, and we touch a lot of bases and we reach a lot of students of varying ages and skill levels. And we hope to expand on all of those offerings.
I really wasn't a history buff until I moved to Sutter Creek. And I saw, what was here and what was falling apart, what there was that, I thought could be saved. One of the things that they had there at the Lincoln Mine was a stamp mill that was made at Knight Foundry. So that kind of got me started. That evolved into putting a little park. A couple of friends of mine got together and we built Miners Bend Park in downtown Sutter Creek with those artifacts. I love this place. It's really, really unique.